Okay, so here are these logarithms to the base other than to the base e problems. So these all are differentiation problems. So 39 is a product rule problem. And let's write it down. So g of t is equal to t squared times 2 to the t. So we have two functions. And I'm going to redefine this as h, just so we can use f and g for the variables, so the different parts of the product. Okay, let's make sure I was doing it right. So let's call f of t equals t squared. G of t is equal to 2 to the t. So the product rule, we have two terms, t squared and 2 to the t power. Here are the variables, the base. Here the variable is the exponent. So since this is just a power rule problem, we just get 2t for this derivative of t squared. And for this part, our base is 2, so our derivative is the natural log of 2 times 2 to the t. Remember, the derivative of e to the t is e to the t. With the base different, all you have to do is multiply it by the natural log of the base, and then repeat this. So it's not natural log of 2 times e to the t, it's 2 to the t. So at this point, all we have to do is say that the derivative of the product is f of t times g prime of t plus f prime of t times g of t. So we just alter one is the derivative, one is the regular function, and then we just plug it in. So you get t squared, which is f of t, times g prime of t, which is the natural log of 2 to the t, and then we add the second part, which is f prime of t, which is 2t, multiplied by g of t, which is 2 to the t. So we're going to be able to simplify this a little bit because we can factor out a t, because we have at least a t in both terms, and we can factor out a 2 to the t. So if we put this out in front, t times 2 to the t power, and what that leaves here is natural log of 2 times t, because we still have one t left over, and the second part is we just have 2. So that would be the derivative. T 2 times 2 to the t times the quantity natural log of 2 times t plus 2. Our second problem in this section is 40, which is just the quotient rule. And I'm going to go ahead and rewrite this. Instead of f of t, I'm going to use h. So we have 3 to the 2t divided by t. So our numerator in the quotient is 3 to the 2t, and our denominator is t. So just like with the product rule, we take the derivatives of each term in the quotient. So when we have base other than e, we always put the natural log of the base, and then you multiply by 3 to the 2t. The only difference is now we use the chain rule. So rather than having just 1 here, if it was just 3 to the t, it would be just natural log of 3 times 3 to the t. But because we have 2t, we take the derivative of 2t, which is 2. And that would, this additional part is the chain rule associated with this exponent. The derivative of that is 1. T with respect to t is 1. So then the quotient rule says that h prime of t, made up of course, f of t in the numerator and g of t in the denominator, we take g of t times f prime of t minus g prime of t times f of t, all divided by g of t quantity squared. So it's just a matter of plugging it in. Let's see if we can get simplify. So g of t is t from here. Then we have times, I'm going to go ahead and move the 2 to the front. 2 times the natural log of 3 times 3 to the 2t. So that's this first part. And then we do this other cross product and we subtract it. So it's just going to be 3 to the 2t times 1, which I'm just going to put the 1 out because it's equivalent. And then g of t squared. G of t is t. So we get t squared. And probably the only thing we really can do much with is we could factor out a 3 to the 2t. And that leaves 2 times the natural log of 3 times t minus 1, all divided by t squared. And I just put it out front because it's a little easier to, it's not a whole lot of difference between the two. I could have divided both these by t. You know, another option would be to do this, 2 natural log of 3 divided by t minus 1 over t squared. And so actually I like the first one better, so that's one I'd use. Okay, so this is problem 44. I ended up making a mistake, so I'm redoing again. It was a small mistake. Problem number 44, what we do is we use the properties of logarithms to break out this expression. So we have a product and a quotient. So we can rewrite this as log to the base 3 of x plus log to the base 3 of the square root of x minus 1, because we're multiplying these two terms together. So we can then change them into the sum of the logs. And then the 2 is in the denominator, so we subtract that, log to the base 3 of 2. Then we rewrite this as a fractional exponent. So it's x minus 1 to the 1/2 power. That allows us to bring this exponent out using the third property of logarithms. So we get 1/2 log to the base 3 of x minus 1. We haven't actually taken the derivative yet. We've broken it down to 3 terms. Here we'd have to use the product rule. But here we don't have to use the product rule. Okay, so the derivative of log to the base 3 of x is the same as the derivative of the natural log, which is 1 over x, which you divide by 1 over the natural log of the base. Likewise here we have 1/2 as a constant, which we bring down. The derivative of 1 log to the base 3 of x minus 1 is 1 over x minus 1. You also, again, divide by log to the base 3. The chain rule would say that we need to multiply by the derivative of what is in the parentheses. That is just 1, because the derivative, the constant is 0, the derivative of x is 1, so I get 1. And this last term doesn't stay the same. And then finally, actually that's it. Okay. Now, how would you evaluate log to the base 3 of 2? Well, the same way that we use to derive the derivative expression. So log to the base 3 of 2 is equal to the natural log of 2 divided by the natural log of 3, where 2 is the argument and 3 is the base. So we can do those on our calculator. We can take the natural log of 2 and the natural log of 3. Remember, you could also do this another way if you wanted to. You could do log to the base 10, which is the log function on your calculator. And you divide by the log to base 10 of 3. So I'm going to get my calculator out. Why don't you get it out and just prove that this is true. So we'll do both of them. So the natural log of 2 divided by the natural log of 3 gives me 0.631. And the second one I use the LOG function. So log to the base 2 divided by log LOG to the base 3 is 0.631. So it does work. These two functions are in your calculator. And another little aside, how does a calculator calculate the logarithm? Oh, I forgot there was actually a little bit more involved here, and I need to correct those as well. The only difference is that I divide by 1 over the natural log of 3. So, maybe go back to how do we get natural logs? Well, there's what's called infinite series representation. So the calculator has an algebraic way of calculating that. And then if we wanted to find log to the base 10 of something, we could use this same type of relationship. So if I wanted to find out what is log to the base 10 of 12, for example, what we do is we would take the natural log of 12 divided by the natural log of 10, which the calculator can do. Let's just prove that's right. So if we put log of 12 in there, into the calculator, the left-hand side is 1.079, and if we take the natural log of 12 divided by the natural log of 10, I get 1.079. So it does work. So really, the calculator probably doesn't calculate this directly. It calculates these directly, and then uses the quotient to get the base 10 stuff. Okay, back to the simplification. All I did here was factor out 1 over the natural log of 3. That left me with 1 over x plus 1/2, 1 over x minus 1, and then I found a common denominator, which was just the product of the two denominators. 2 times x minus 1. So to get the numerator, we take these terms in the denominator multiplied by the numerator, which is just 2x minus 2 times 1, which is 2x minus 2. And then we take the cross product here, which is x times 1, which is just x. So you get 2x plus x, which is 3x. We have the negative 2. And then our common denominator. So that's... Okay, so this is our last problem in this section, which is problem 48, I think. So we have f of t is t to the 3/2, simple power rule, times log to the base 2 of the square root of t plus 1. And again, I'm going to call that h. So it's a product of this term and that term. So we're going to call f of t, t to the 3/2. G of t is log to the base 2 of the square root of t plus 1. So product rule, you take the derivatives of these two, and then you multiply, do the cross product here with the results. But before we do that, before we take the derivative of this, we can use the properties of logarithms. We just did it in the previous problem, so I'm just going to show you the results. So we can change this into a fractional exponent, bring the half out, and you get that. So now that we take the derivatives, f prime of t is 3/2 times t to the 3/2 minus 1 power, which is to the 1/2 power. So that's the first term. The second term, g of t, when you take derivative, you'll have the constant, 1/2, times the natural log of 2 times actually it's divided by, isn't it? Yeah, it's divided by, I'm just going to do the problem over again. Oh well. Okay, so it's 1 over the natural log of the base times 1 over the argument times the derivative of the argument, which is just 1. So g prime of t is going to be 1 over 2 natural log of 2 times 1 over t plus 1. Okay, so Now we just plug into the quotient rule. Quotient rule, remember, h prime of t is equal to f of t times g prime of t plus f prime of t times g of t. F of t is t to the 3/2. G prime of t is 1 over 2 natural log of 2 times 1 over t plus 1. So that's that. And then we do the other ones, which is going to be plus 3/2 t to the 1/2 times g of t, which is 1/2 log to the base 2 of t plus 1. This times that. So what can we do here? We can factor out t to the 1/2 power and 1/2. Actually, let's factor out a 4. That'll make it so we don't have a fraction there. So if you do that, we'll get 2 divided by the natural log of 2 times 1 over t plus 1. That's the first term. Notice 2 divided by 4 is 1/2. So I get 1/2. That's a 1/2 thing. And let's see, also I need a t right here as well. T. So I get t to the 3/2. And the second one, these 2's will factor out, so we'll just have 3 times t to the 1/2 times the log to the base 2 of t plus 1. And I think that's right. Oh, no, I don't need that. I don't only include t to the 1/2 because I just factored it out. So it's just 3 times that. Okay, looks correct to me.